let's talk about limits of a function. If this is your first time watching my video, consider subscribing, follow my page. Please like and share this video to your friends. For the purpose of this video, we are basically going to talk about the three most common ways of obtaining limits of functions. We have the plug-in method, the factoring method, and the expanding method. Now, these formulas, these methods will help you to obtain limits based on the type of problem you have, right? And we have the limit of x squared minus 2x minus 3 all divided by x squared minus 9 as x tends to 4. And in this case, as x tends to 3, in this case, x tends to 0. Now we are going to apply this method, the first method in our list, to see if we can actually obtain the limit of this function. But you should also remember that in most cases, the first method may not work. So when the first method fails, you apply the second method. When the second method fails, apply the third method. And when the third method also fails, you just try to, apply as many methods as possible before you can actually say that the limit of the function you were given does not actually exist. So from our first problem we need to use the plug-in method to see if we can actually obtain the limit of this function. And this method is basically, we have that x is tending towards 4, right? It's basically substituting x. Anywhere we find x in the numerator and the denominator, we substitute 4 for x to see if we can actually obtain the function, the limit of the function. So we have for the limit as x tends to 4. Now, anywhere we see x, we substitute 4, right? So we'll have 4 squared minus 2 times 4 minus 3, all divided by 4 squared minus 9. So if you evaluate this, we have 5 over 7, right? So this means that the limit of this function, x squared minus 2x minus 3 over x squared minus 9 as x tends to 4 is basically 5 over 7. That's correct. So now let's move to the next problem we have on our list. And we have for this, we have the limit of x squared minus 2x minus 3 all divided by x squared minus 9 as x tends towards 3, right? Now we are going to also use the plug-in method just to see if we can actually determine the limit of this function. We have the limit as x tends to 3. Now anywhere we find x, we substitute 3, right? So we have 3 squared minus 2 times 3 minus 3 all divided by 3 squared minus 9. So basically, this is equal to 0 over 0, which basically does not make any sense, right? Cool. So what we need to do right here from this point, we need to check if there is anything we can actually factorize in this problem. We need to check if we can factor out anything, and that is where this factoring method comes into play, right? So if we take a good look at this, on the numerator we have a quadratic expression and we can actually factorize this. Now for the denominator we have x squared minus 9, which we know that using the law of difference of two squares, since 9 is a perfect square and we have x squared, we can actually use the law of difference of two squares to factor out x squared minus 9. And if you factorize x squared minus 2x minus 3, we have the limit as x tends to 3, x minus 3, x plus 1, all divided by, using the difference of two squares, we have x plus 3 and we have x minus 3, right? So let's see if we can actually cancel any common factor as the case, as what we have at hand, right? But you can notice that we have x minus 3 on the numerator and we also have x minus 3 from the denominator. So these two factors can actually cancel out. Then we are left with the limit as x tends to 3, x plus 1 all over x plus 3. Now, if you look at this, you will discover that we can no longer cancel anything here, right? So now we apply the plug-in method. Remember that when we plugged in 3 for x, we obtained a form where the limit does not exist. Now, let's see if that will be the case again. So when we put 3, we'll have 3 plus 1 divided by 3 plus 3, which is almost the same thing as 2 over 3, because we obtain 4 over 6 and 2 can still cancel out. So we'll have 2 over 3. Right. So this is actually the limit of this function. But we obtain this limit by the help of the factoring method. We see that by plugging in the values, 3 for x, we obtain an indeterminate form of limit, right? This limit does not exist at this point. So we cannot just leave it this way, and we decided to factor, and now we have gotten the limit of this function. So let's take for the last problem we have on our list. We have the limit of x plus 2 in bracket raised to the power of 2 minus 4 all divided by x, as x is tending towards 0. So basically, if we apply the evaluation method, which is the plug-in method to, if we use the plug-in approach to this problem, we have that the limit as x tends to 0. Without anywhere we find x, we substitute x for 0. So we have 0 plus 2 squared minus 4 all divided by 0. So this squared will give us 4, and basically what we have here is 0 over 0, which does not exist. Right. So what else can we do? Now we need to expand what we have in this parenthesis to see, to make this work simpler, or even see if we can actually cancel our common factors, right? And that is where the expansion process, or the expanding method comes into play, right? So when we expand x plus 2 all squared, we will obtain a quadratic expression, which is x, as x tends to limit, as x tends to 0, we have x squared plus 4x plus 4 all divided by x. Now remember, we have a negative 4 right here. So basically positive 4, negative 4 goes, and we are left with the limit as x tends to 0, x squared plus 4x all over x. Right, so we can factor out x from this, and we have that this will be equal to x plus 4, right, all divided by x. Now x takes x, we are left with the limit as x tends to 0, x plus what? X plus 4. Now let's also apply the plug-in method to see if we can obtain the limit as against what we had from the very first beginning. Now when we substitute 0 for x, we have that x, the limit will now be equal to 0 plus 4, which will be equal to what? 4. So basically we have seen that using the expanding method, we have been able to obtain the limit of this particular function that we have right here. So the catch is, when you have a problem, you first test for the plug-in method, but when you obtain your limit, fine. But if not, also try to see if you can factor out, also try to see if you can expand in the case of this parenthesis we have right here, raised to power of 2, maybe 3, maybe 4, as the case may be. Right. So this is basically what we have using these 3 methods of evaluation of limits. But in our next class, we are going to be taking more complex problems on limit. So hope you enjoyed the video. Make sure you like and share this video to your friends. Hope to see you on our next class. Bye for now.